Hey everyone, this is Mr. Bonifaci. So as you know, I'm not here today. If you're watching this video, this just might be recording, that type of thing in future years. But yeah, I wasn't here today. And we yesterday did the flame test lab. And the whole goal of this thing is to explain, like, why did we get those cool, like, red colors or green colors or other colors that came off those flames? Like, why in some cases this and why in other cases that? So what causes matter to give off light, which will ultimately connect to stars? Okay. Now, if you are at school watching this, you should have a note-taking sheet, and you'll just fill out that note-taking sheet as you go along. If you've lost that note-taking sheet, you could also just draw it in your journal, but that's just a lot more work than filling in the blanks. So, yeah. Anyway, here we go. Let's rock this pretty quick. So, okay. So nothing to write down during this first part. All you have to do is think about it. Okay. So, we're going to use a building as an analogy for an atom. So imagine that here's our building here. It's an atom. It's a building. Okay. Imagine several people live in an empty skyscraper. Okay. The building's super tall and the elevators are broken. Okay. So you have to take the stairs. Okay. So given that people who live there need to come in, they need to move in, they need to move out, they need to carry groceries, whatever, friends come visit, right? Plus all that stuff, what is the most ideal floor to live on? And in the answer here, I mean, you might have your own personal choice. If it all got pulled in the answer, probably the bottom floor, because you wouldn't have to carry things up and down. Okay, less energy would be spent on the bottom floor. Okay, so the people would live on the bottom floor. Now, if the bottom floor was full, okay, and they couldn't live on the bottom floor, they would live on the second floor. And if you guys remember from before, we talked about there's two energy levels, like 2 electrons in the bottom energy level. So if the bottom 2 were empty, right, you'd live on the second floor. The second floor has 8 rooms. If they were full, you'd live on the third floor. If the third floor is 8 rooms, if that was full, you'd live on the fourth, and so on. You get the analogy. Okay. So that's how things get full in general, right? Of electrons. Like first floor gets full, second floor, third floor, fourth floor, right? In our building here, it takes less energy to live on the bottom floor. Okay. Okay, now here's where it's gonna get exciting. We're gonna add energy. Okay. Now in real life, like with atoms, energy is like fire, hint, like the lab, or electricity, like in light bulbs. But in our case, energy is gonna be gummy bears, lots and lots of sugar. Okay. So would they stay on their floor? And especially, like, imagine kindergartners. Like, if you gave them a ton of energy, are they going to stay on their floor? No, of course not. These excited people are going to run up and down stairs throughout the whole building. Okay. In fact, the more energy you gave them, the higher they might go. Okay. So until they got tired, and then eventually they would collapse back to their bottom floor, wherever their home is, back to rest. Okay. So how does this apply to an atom? Okay, so here's an atom here. The whole atom is the building. The different floors are energy levels, like first floor, second floor, third, you get it, and so on. And people are electrons, okay? The more sugar you give them, the more energy. So here is where we start writing stuff down. Okay, anything in red collates to the sheet pretty well. Okay, now again, if you and the date's wrong, apologize, that's last year. So okay, so electrons are normally in a ground state. Okay, so in a ground state, like when we drew them before, ground state is with the standard amount of energy. Okay, so it was in a ground state. Okay, now when they absorb energy, okay, so and here's kind of like the first box, and here's a second box. Okay, in the ground state, this is the standard one. Okay, it's going to absorb energy, and that energy could be from like lighting on fire, like yesterday. It could be from giving electricity. We give it energy in some way, and when it gets energy, it hops up. Okay, it hops up to a higher energy level. It might be 1 energy level up. It might hop up 2 energy levels. It hops up at other energy levels as they get there. Okay, so now, so there we go. Okay, so again, you filled in box 1, box 2. box 1, box 2. You fill in any blanks you need to. Okay, and again, you can pause it if you need to, right? Okay, so here's the next 2 boxes. So after it got that energy, what happens next? And you can draw these in there if you're drawing your own, or just fill in these boxes if you have the sheet. Okay, so we call it excited. So as it's up here, this excited atom, it doesn't hold on to that energy, eventually releases it and collapses back down. Okay, and when it goes back down, it gives off light. Okay, so what's going on? In fact, this is why our lights in our ceiling give off light the whole time, where we're giving them constantly electricity. And as they get that electricity, they get excited, they hop up and they hop down, and then when they hop back down, they give off light. But we give them more electricity so they get excited and come back down, give off light. And we give more energy and they get excited and they come back down, they give off more and give off light. So they're going repetitive. So back to ground state, and then what would happen is we give them more energy and they get excited and they come back down and they give off light. And in fact, if you look at old lights, like old fluorescent lights, they flicker. This is part of the reason why they're flickering. The newer ones are better about like some hopping up and down at different times, and it gives them more constant level of light. But for these that don't have that, yeah, so hopping up and down, and that's why. And when you burn something, you gave it energy, and then it would hop back down. It gave off that red light or that green light or that type of thing like that. Okay, so there's the before and the after. Make sure to label. Okay, now this, remember when we used this spectroscopes before? Okay, so when it gave off for hydrogen, for example, we saw it have red and then kind of a blue green, and then also like some darker lines up here on purple. Okay, each different color is caused by a different hop down. Okay, so couple things you have to remind yourself from. Okay, the farther an electron drops, the more energy it's giving off. So the farther it drops, the more energy. Okay, so for example, in this picture, a drop from here to here will be a ton of energy. A drop from here to here, just a little bit of energy. Okay, now remember, more energy is higher frequency. Okay, so the higher the frequency, the more energy. And so, okay, and the more energy, the more purple or even beyond purple. Remember, we only see visible light, but if you had more energy, it might be ultraviolet or even gamma, right? So the farther it drops, the more energy, the higher frequency, the more purple. The less energy drops would be something more like a red that's not dropping as far, or even like a radio wave. Okay, so in that way here, if we gave it a lot of energy, okay, it would be doing a drop from this. If we gave it just a little bit of energy, and so on downward. Now you might be like, we all burn them the same. Different atoms have different electrons at different spots. And those different electrons at different spots means they can give off different colors. Okay, so that's why the hydrogen gave out the certain colors it did, because it can only do drops from those heights, because it had those set of electrons. Why iron would have a different set of electrons, or copper would have a different set of electrons, and because they have a different set of electrons, they can do different drops, which add up to different colors. Okay, so the last thing I wanted to show you, not that one, but this one right here. This is one of those links right there. So we can give it different amounts of energy. So if we give it a little bit of energy, it just hops up a little one, and it's stuck there until it drops back down, releasing energy in that case right there. Okay, now if we give it more energy, it hops much higher up, right? And then it can do these different types of drops along the way, and it can get back down to the bottom. But remember, the farther it drops down, the more purplish the light, the more energy, and the smaller drops would be more reddish in energy. So hopefully that helps. So now what you're going to do is you're going to go ahead, and you got the notes done, check. You're going to go ahead and do the questions related to the lab from yesterday. So thank you very much.